Okay, um, just a real quick review. Um, in the first video, we talked about what it means to be a solution to a system of equations. And we went through some examples, and we basically said that it's the point, or the x comma y, that works for both equations. And that's what the solution is. So when we go to learning target 2, to find the solution. Learning target 1 was all about like, here's the solution, maybe, is it yes or no? Um, Learning target 2, you're going to be given two equations, and the goal is to find the actual solution by graphing them. And so remember, again, the solution is just the x value and the y value that works for both equations. So that kind of idea stems right into learning target 2. Um, to or the solution of a system of equations, solving it graphically, we are looking for the only shared point that's on both lines. That's kind of our key. The only shared point that's on both lines. In other words, what is the x comma y? What is that point? Only shared point. What is this point that is on both lines if we graph them? Or in other words, if you graph the two lines, we're looking for where the two lines intersect. Okay, so if this is the line of one equation and this is the line of the other equation, this is the only point that they share, the only shared point. So whatever the coordinates are of this point, that is the solution, and that's where they intersect. Okay, so go ahead and get those couple things down real quick. You don't have to draw the diagram if you don't want, but if a visual helps you, there it is. Pause if you need to. Go ahead, write those down. Otherwise, here are some examples. In this first one here, and in all these examples, we're going to solve them by graphing. And so the way to do that, which I kind of already told you, is to graph both equations and find where they intersect. So this first one, we know how to graph lines. This shouldn't be all that difficult. Maybe you need like a real quick refresher, but again, this last part, that's the y-intercept at 4. We have a slope of -3, so I'm going to go 1, 2, 3, down 3 over 1, down 3 over 1, make a couple points there. And then again, this shouldn't be all that difficult. Hopefully we at least kind of remember how to graph lines. The second one, 1, 2, 3, 4, y-intercept of -5, and then it's got a slope of 6. So up 6 over 1, up, and it kind of goes off the graph, but it'd be somewhere up there. Okay, so our line sort of looks like that. And it was fairly obvious this is the shared point. This is the only shared point. So if we're looking for one point that's on both of these lines, this is the only point that's on both of the lines, because they're going to keep on extending forever and they're only going to get further apart. So this intersection here, that's the only shared point. So the solution to this system is 1, 1, or x equals 1, y equals 1. Okay. So as kind of usual, I'm just gonna do these other ones in a little bit less detail, but you kind of get the idea. This x minus 4, start down here at -4, and we've got a slope of 1, so that's just going to look like this, going up 1 over 1 each time. This second one we'll have to do a little bit of work, and this was one of our tougher learning targets, I think, from Unit 1. But if we're going to graph this, we're looking for an x-intercept and a y-intercept. I'm going to plug in a 0 for there. 3y equals 6, so y equals 2 when x equals 0. And and when y equals 0, x also has to equal 2. Okay, so we have y-intercept of 2 and an x-intercept of 2. And if you kind of need to look back at Unit 1 a little bit to kind of refresh yourself on how to graph something like that, then please feel free or ask me in class or something. But again, that's not really the focus. The focus is sort of looking for where is the actual solution. And in this case, our intersection is right here. That's the only shared point between these two lines at 3, -1, or x equals 3, y equals -1. All right. Now there are some special cases. If you remember our other special cases, it's pretty similar. In previous units, we looked at special cases like infinite solutions, no solutions, and that's basically what these are. If I graph these two lines, both have a slope of 3. There's the first one. And the second one has a y-intercept at 1, and then a slope of 3. And so if you notice, these two lines are both parallel. That's because they have the same slope. We've talked about that maybe just like real quick at some point in the year, but if two lines have the same slope, then they're parallel. And if two lines are parallel, you know, because you've talked about parallel before, you know they're never ever going to cross. And so if these never ever cross, they don't have a shared point ever. They don't have an intersection ever. And so because they'll never cross, because they're parallel, these two things do not have a solution. There's no solution to this system of equations. You could try and try forever and ever, guess and check x and y combinations, and you would never find a solution to this. Okay, so that's if you see that two lines have the same slope, you know they're going to be parallel, so you know there's going to be no solution. And this is just that the graph kind of shows you that visually. All right. In this second one here, 2, 3, 4, slope of -2. This one, when x is 0, looks like y is going to be 4. And when y is 0, x is going to be 2. So there's my 2 points, 0, 4. And I'm going to do this one in red just so you can see it a little bit better. So this one's going to be in red. But 0, 4 is on the graph. 2, 0 is also on the graph. And so with those 2 points, what we end up with is these two equations are actually the exact same thing. So in this system of equations right here, these two lines end up being right on top of each other. And if you go back to kind of thinking about what is a solution, it's where the two lines intersect. Well, the two lines intersect everywhere, all at the same time, every single possible point. If you wanted to write one of the solutions to this system is 2.2 comma negative 0.44444, like, I don't know, maybe. I'm kind of estimating. But there are an infinite number of possibilities for the solution here. And so this is a special case where we would have infinite solutions. These two lines intersect at an infinite number of points. And so there have to be an infinite number of solutions. All right. Those are our two special cases. If only the slope is the same here, then there's going to be no solution. If the slope is the same but different intercept, it's no solutions. Over here, if we have the same line, that means they have the same y-intercept, which was right here, and they also have the same slope. It's tough to tell from just looking at these two equations. It's tough to tell that they have the same slope, but when you graph them, you can see obviously they do. Obviously they have the same y-intercept, and so they're the same exact line. They have this infinite number of solutions. Your before class, it's just a couple of, here's your system of equations here. And it's just asking you to find the solution by graphing them. And if they don't line up, I guess I should have mentioned this earlier, if they don't, in all these examples, they kind of lined up at really nice points here. They might not necessarily always do that. So if they don't, then you just kind of have to estimate, okay, wherever kind of looks like the intersection is.